Lesson 317, Slope, Part 2. The objectives of this lesson is to use the parallel lines theorem to solve problems, to use the midpoint formula to solve problems, and to use the perpendicular lines theorem to solve problems. The parallel postulate states that if you have a line and a point that is not on the line, then there is only one line through that point that is also parallel to the given line. Well, that can sound like a lot of mumbo jumbo, so I put together this little graph that I've found in the LMS, but I changed it up a little bit. Now, the line is this red line, okay? That's the line they're talking about when they say, states that if you have a line, and then it says if you have a point that is not on the line, here's the point not on the line, then there is only one line through that point, which is this blue line, that is also parallel to the given line. If right now the blue line and the red line are parallel, but if it was slanted even just the slightest bit to the left or right, then they wouldn't be parallel. So that's your parallel postulate. And let's do some slope calculations like we did in our last lesson, 316. And we're going to use that formula m equals y2 minus y1 over x2 minus x1. So for C, I not always, just the way you see me doing right now, and even as a teacher teaching this, I always label my points before I start filling things in. So I've got my slope. My y2 is going to be a positive 5 minus y1, which is also a positive 5, over x2, which is 1, minus a negative 3. So when I simplify this, I get a 0, and you remember that whenever you have two negatives, it makes it a positive. So 0 cannot be divided by any number, so it's just always going to equal 0, or 0 divided by 4 is just going to give me 0. So for C, the slope is 0, which makes sense because if you have a straight line, say if you're on a flat road, then it doesn't have any steepness at all. It's going to be flat, so it has a slope of 0. Now for part D, let me label. This is x1, y1, x2, y2. Now I'm going to plug everything in, so y2 is going to be a negative 1 minus 3, and then x2 is 6 minus 6. So negative 1 minus 3 is going to give me a negative 4, then 6 minus 6 gives me 0. Well, no number can be divided by 0, so we always call this, anytime we have something divided by 0, we call it undefined. Now, some teachers in your past may have just said no slope. The proper term is undefined. So when it's going straight up and down, of course it's very steep because it's going straight up and down, but that means that it's absolutely undefined. So anytime you have a horizontal line, it's going to be a slope of 0. Anytime you have a vertical line, your slope is undefined. Now, if two non-vertical lines, this is postulates for the parallel and perpendicular lines, it says if two non-vertical lines have the same slope, if and only if they are parallel. So basically what we're saying is if you've got a set of parallel lines, they're going to have the same slope every time. If you have perpendicular lines, the product of their slopes will always be negative 1. And another way to look at this is that you're going to have opposite reciprocals. Opposite reciprocals. So if I have a slope of 1/2, then the perpendicular slope is going to equal negative 2 over 1. So see, this is positive, opposite is negative. The reciprocal, you got 1 over 2, its reciprocal is 2 over 1. So, and if you look, if I say 1 over 2 times negative 2 over 1, 1 times negative 2 is going to give me negative 2. 2 times 1 is going to give me 2, which equals negative 1. Alright, let's work this example here, number 3a. It says to determine whether line AB and line CD are parallel, perpendicular, or neither. So what I always do first is I go through and I label. For line AB, I'm labeling them x1, y1, x2, y2, and then for line CD, I'm doing the same thing. So there's y1, x1, y1, x2, y2. Now remember, you're setting up your slope formula. You're going to have m equals y2 over y1 over x2 minus y1. So for line AB, I'm going to come up here and I'm going to say y2 is 7 minus a negative 5 for y1, and then x2 is 4 minus a negative 2 for x1. Remember, these always, two negatives make them positive. 7 plus 5 is 12. 4 plus 2 is 6. 12 divided by 6 will give me 2 over 1. So for line CD, remember you always simplify. That's how I got the 2 over 1. y2 is negative 2 minus 2 for y1. x2 is 8 minus a 0 for x1. So it gives me a negative 4 over 8. Both of those are divisible by 4, so I get a negative 1 over 2. Well, I can tell they're not the same, so now I'm going to test to see if they're perpendicular. If I take 2 over 1 and multiply it by negative 1 over 2, I'm going to get a negative, because a negative and a positive make a negative. 2 times 1 is 2. 1 times 2 is 2, and that reduces to negative 1. So line AB is perpendicular to line CD. That's exactly how that works. So let's look at this next one. Let me change pen colors just in case I get too close so we can tell who's who. I'm going to go with green. x1, y1, x2, y2, and then for line CD, x1, y1, x2, y2. So for AB, I'm going with negative 4 minus a negative 7 over 4 minus a negative 8. Remember, two negatives make it positive, so 4 plus 7, oh wait, excuse me, negative 4 plus 7 would give me a 3. 4 plus 8 will give me 12. 3 will go into 3 once, 3 will go into 12 4 times. So that's reduced, so let's look at line CD. I've got 7 for y2 minus a negative 5 for y1. x2 is 1 minus a negative 2 for x1. Got to make them positive. 7 plus 5 is 12. 1 plus 2 is 3. Those will go in. 3 will go into itself once, go in there 4. Okay, I have opposites. I have reciprocals. But if I multiply them out, if I got 4 over 1, I'm going to get 4 over 4. And remember, that comes out to be a positive 1. It has to be negative in order for them to be perpendicular. So these guys are neither. Okay, now we're going to do this example. It says graph the line that contains point P negative 2 and a positive 1, and it's perpendicular to line JK with j being -5, -4, and k being 0, -2. So what I'm going to do is I'm going to plot all these points. P is -2, 1, so I'm going to go 1, 2, and then up 1. So there's point P. And then I've got line JK. J is -5, -4. 1, 2, 3, 4, 5. 2, 3, 4. So right there is J, and then K is 0, -2. And there's K. Well, let me see if I can't get lines drawn through here that look halfway straight. Alright, there's my line JK. That's about as straight as I'm going to get it. And now I have to calculate what is the slope of JK so I can figure out a second point for point P. So I can create that line. So let me go down here to my pen, and I'm going to write up here a slope, and I'm going to put up here x1, y1, x2, y2. So I'm going to have a -2 minus a -4, 0 minus a -5. Remember, positives. So -2 plus 4 is going to give me 2 over 5, and that's going to be my slope for line JK. So remember, it says up here that P, the line that contains P, is perpendicular. So that means it has to be an opposite reciprocal. So the opposite of a positive 2/5 is negative. The reciprocal of 2/5 is 5 over 2. I'm going to write out here opposite reciprocal. So I could have also done this way. I could have went over here and drew my triangle. I could have said my rise here is 2 and my run is 5. So that means up here from point P that my run is going to be 2. Oops. And my rise is going to be 5, but it's going to be going down instead of up. 2, 3, 4, 5. So my new point will be right there. Okay, so let me see if I can make me a line now for that point P. There we go. That's about as close as I'm going to get. And recall that we said they were perpendicular, so anytime you have perpendicular lines, it's going to create right angles. So there you go. And again, remember, whenever you're graphing lines, be sure to put the arrows on the end. Okay, let's go on and see what we have next. It says graph the line that contains point 0, 1 and is perpendicular to QR. And there's my points. So the first thing I'm going to have to do, I can plot or I can find my slope. Either one is going to work. So x1, y1, x2, y2. So here's my slope of QR is going to be -6 minus a -2 over 0 minus a -6. So those two negatives become positive, so I've got -4 over 6. Both of those can be divided by 2, so I'm going to have -2 over 3. And let me go ahead and plot these. I've got Q is -6 and 2. 1, 2, 3, 4, 5, 6, -2. So there's going to be my Q. And then my R is 0, -6. 1, 2, 3, 4, 5, 6. Okay, so there's my R. And let me draw a line through those. There we go. That looks like about as good as it's going to get. And remember, after you draw this line, you can also do the rise over run. I was going to change my ink color here right quick. So if I did the rise over run, I'd go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. See how it would be 4 over 6? It's sloping down from left to right, so that's where I'd get my negative Let me circle that. Looks like an equal sign if I don't. So remember, and then that's going to simplify to negative 2/3. So if I want to find the perpendicular slope, my perpendicular slope is going to be my opposite. Opposite of negative is positive. The reciprocal of 2/3 is going to be 3/2. They told me that point P was 0 for x and 1 for y. So there's my point P. Now then, I want to go up 3/2. 1, 2, 3, 1, 2. Now I'm going to come over here. If I want to go down to my line, I can just go 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. All you got to do is just exactly the opposite. 1, 2, 1, 2, 3. There's a line, or there's a point. 1, 2, 1, 2, 3. There's another point. That's just to help me see where it's going to be intersecting the line at. So let me get a line drawn for that. Well, that one didn't take me near as long to get drawn. And remember that after I have created perpendicular lines, they form right angles. First, let me show you what that formula looks like. It's a capital M. These are also on your formula chart. You got x1 plus x2 divided by 2. Then you've got y1 plus y2 divided by 2. That's your midpoint formula. So it says find the coordinates at M, the midpoint, for segment JK. And they tell us that J is negative 1, 2. K is 6 and 1. So I'm going to label those because I like to label. And now I can come over here and say, okay, x1 is going to be negative 1, x2 is going to be 6, that's all divided by 2, y1 is going to be 2, plus y2, which is 1, that's all divided by 2. So I get 5/2, which can't be reduced, and I get 3/2, which cannot be reduced. So that right there equals my midpoint for segment JK. Now then, this one down here in the bottom, it says find the coordinates for midpoint segment AB. Didn't really leave enough room for me to work it out, so I'm going to put this x1, y1, x2, y2. So I'm going to have that my midpoint equals 5 plus negative 4/2. My y is 12 plus 8/2. Put them in parentheses. So now I have that my midpoint equals 9/2 and 16/2. Well, my x, it can be, you can go ahead and make that 4.5. As long as it's a terminating decimal, I'm okay with it. But if it was a repeating decimal, I'd prefer you leave it as a fraction. And then 16 divided by 2 is 8. So that's going to be my midpoint for segment AD. Right there, 4.5 and 8. Okay, these kind of problems right here are my favorite because I get to do a little bit of a different line for them. And instead of using the formula, I come up here and it tells me to find the coordinates of x if y is my midpoint and z has the coordinates 2, 8, and I have this segment xz. Well, I always start with the end point I know, which is z, and they're giving me 2 and 8. Then I draw me a line going down. No, doesn't even have to be straight, obviously. This is going to be x, and I don't know what point x is. And then I have a midpoint of y, and they tell me those coordinates are negative 1, 6. So what I do is, to help you see what I'm doing here, I'm going to change my ink color. I'm going to find out on the number line what is the difference, or how many units are between 2 and -1, how many units are between 8 and 6. I'm going to take those units and add them to the midpoint, and that's going to give me the point for x. So let me change my ink color again. So from 2 to -1 on the number line is 3 units, okay, because I'm going, there's 1, 0, 1, 2, so I'd go 1, 2, 3. It's 3 units. And I would have to subtract 3 from 2 to get -1. What would I have to subtract from 8 to get 6? Well, that would be -2. So I'm going to take those same numbers and add them to my midpoint. So I got -1 plus -3 is giving me -4. 6 minus 2 gives me a +4. So the coordinates for x are -4 and 4. So you can think of it as a number line, or you could think of what would I have to subtract from 2 to get -1, what would I have to subtract from 8 to get to get 6. But whatever numbers you get here, you're going to add to the midpoint to find the other endpoint. So this down here says find the coordinates of G if P is -5, 10 is the midpoint of segment EG and E has the coordinates of -8, 6. So I always start with the endpoint I know, which in this one is E. Then I draw me a straight line down. The other endpoint is G. My midpoint is P, and that's -5 and 10. Let me make sure that negative sign shows up. So what would I have to add or subtract to -8 to get -5? Well, I would have to add 3, and to get from 6 to 10 I would have to add 4. So I do that to the midpoint. -5 plus 3 is going to give me -2. 10 plus 4 gives me 14. So the coordinates of G are -2 and 14. And that's how that works. Okay. These we're just doing the same exact thing, except we're just using algebra to find our points. They said find the measure of segment BC if B is the midpoint of AC. Well, we know that if B is the midpoint, that means AB is congruent to BC. Anytime you have expressions that are congruent to each other, when you want to solve for x, you set them up equal to each other. And I kind of put the cart before the horse. What I should have written here was that AB equals BC. So then I substituted the expressions in for the segments. So now I want to keep my variables positive, so I'm going to subtract 2x from both sides. I get -5. 2x minus 5 equals 11. I add 5 to both sides. I get 2x equals 16. Divide both sides by 2. I get x equals 8. But it asks me find the measure of BC. Well, BC equals 11 plus 2x. So I plug in 8 for x. So I get 11 plus 16, and that's going to give me 27. And that's the length of BC. Let's do one more problem like that. It says find the measure of xy if y is the midpoint and of xz, and xy is 2x plus 3 and yz is 6 minus 4x. So I'm going to draw me a line segment. They told me this was x, this was y. Oh wait, no. Y is the midpoint. This is z. They said xy is 2x plus 3 and yz is 6 minus 4x. So I know that xy is going to equal yz, because y is the midpoint. I'm going to plug in the expressions. I want to keep my variables positive, so I'm going to add 4x to both sides. I get 6x plus 3 equals 6. Subtract 3 from both sides. I get 6x equals 3. I'm not liking this. I don't like it when it's funny numbers. X equals 3 over 6, which reduces to 1 over 2. So if I want to find the measure of xy, that's 2x plus 3. I'm going to plug in that half for x. That gives me 1 plus 3, so xy equals 4. And there you go. Alright, to summarize this lesson, we did a lot. Well, the slope of a horizontal line is 0 and the slope of a vertical line is undefined. Parallel line theorem states that two non-vertical lines are parallel if and only if they have the same slope. Vertical lines are parallel. The perpendicular line theorem states that two non-vertical lines are perpendicular if and only if the product of their slope equals -1, and I also pointed out the opposite reciprocal. I'm going to write that down. This is how I abbreviate it. So if I have 3/4, the opposite reciprocal will be -4/3. And a horizontal line and a vertical line are perpendicular. The midpoint formula shows that the midpoint of any 2 points in the xy plane is the average of their corresponding x values and y values. So when you get finished watching this video, you should review the Lesson 317 Slope Part 2 and complete the student guide. Read pages 93 through 98 in the reference guide. Complete these problems in your problem set. If you have any problems understanding the concepts, please contact me or attend TOGA before you complete the 317 quiz. And that, my friends, is going to be the end of Lesson 317. Thank you for listening.